So yeah, let's start. Today we have Avi talking about Python stuff. So
Yep.
that's all I know. So please introduce yourself.
All right. So for those of you who I haven't met yet, my name's Avi Persin. I've been here since June, mostly working on GISTEMP related stuff and stuff on the website. But mostly the GISTEMP analysis, and that's what I'm really that's the main focus of this presentation. I'm gonna talk about different ways that we've improved GISTEMP and different ways that you can really visualize data in general, not just for GISTEMP, but for any data that you're trying to plot. So I'm gonna show you examples from a couple different projects that I've worked on. So the first is gonna be GISTEMP. We're gonna talk about why it needed to be changed, different projects that were started that help to further the change. Then we're going to look at the station locator, which basically plots different all the NASA stations that collect data for the temperature data and things like that. We're going to look at a new matplotlib library that they've added. It's called basemap, where you can plot temperature data onto an actual map of like a 2D map of the world, and you can do some pretty neat things with that. And then we're going to look at a 3D graphic that I've been working on with Jeff, which is also pretty cool for plotting isosurfaces and things like that. I'll give a quick summary for those who don't know what GISTEMP is, just really quickly. Basically, NOAA provides data. They collect data about temperature data, land data, all that kind of stuff, and they put it into a file, and it's on an FTP server. The GISTEMP analysis basically fetches that together with the SCAR data and runs a whole analysis. I'm not going to get into all the details of the actual analysis because that would take probably an entire presentation. But basically what you need to know is that it's a large data set, and it needs to be, there's a lot of different manipulations and gridding that has to be done in order to normalize the data and to make it, to fill in missing parts of the data and things like that, which can take a lot of time if it's not done properly. So why are we rewriting this? It's because the code base right now is mostly in Fortran. It calls a lot of shell scripts. It's not very, it can be improved in ways like that. There's a lot of different things that have to be done in order to actually execute GISTEMP. You have to first go, FTP to the server, grab the data, FTP to this server, grab the data, make sure everything's in the right places, things like that, and you have to run the commands in the right order in order for the thing to run. So the idea is to have a one-stop shop for the GISTEMP procedure, so that you can just click like a run button and it will do all of that for you. Also data validation. Currently data validation is mostly being done by people in GISS who are actually going in and looking at the data, looking for irregularities and things like that that may that look out of the ordinary, and based on that they're going into the data and correcting it and things like that. So that's obviously better if we can do that through the computer, because it takes away human error. It's a lot faster. It will allow us to get all the GISTEMP data out quicker. And it's difficult to maintain code like that. So that's why we looked into this project called CCC GISTEMP, which basically was started, CCC stands for the Clear Climate Code Foundation. They rewrote a large portion of the GISTEMP analysis, and they rewrote it all in Python. A couple things about their rewrite is that they only wrote it for Python 2.7 and lower, so the newest Python versions are not supported. They don't have any graphics, so you can't generate any sort of visualizations after so that you can see the data. It just generated text files that you'd have to scan over. And the other thing is that the goal of their project was specifically to rewrite and copy exactly what the GISTEMP procedure does. So whether the GISTEMP procedure was doing it efficiently or not, they didn't worry about. They just redid it. If it was inefficient, they redid it inefficiently. They just made it exactly the same way. So a couple of things they did is that they still used binary files. They created a class for a Python class that mimicked like the Fortran type file system, and so because of things like that, they were doing binary reads. It was a lot of extra code that wasn't really necessary. So, but that was basically the foundation for this project. Is I took a look at their code and sort of manipulated it and things like that.
Yeah, that was done in 2007 as a response to all those deniers who said the NASA is fudging data and it's doing all kinds of crazy stuff and their programs are no good. So what they did is reprogram the whole thing from scratch. But to test our work, they made sure that they got exactly the same results and thereby could confirm that what we do is reasonable. They found some little glitches, but none of them had any impact on the results.
This was some guy out of Berkeley? Was this guy out of?
No, that was a British company who looked for projects, who tried to introduce or make Python more popular. So they took on various projects and demonstration projects what you can do with Python, and this is one of the things that they did just to basically help us out.
I guess the Berkeley thing was that maybe that was just a whole fresh look at everything,
Right.
and they said, well,
Right.
everybody's
Yeah,
right. There really is global warming.
They weren't concerned with that. We do. They used a whole different method, much more complicated.
Yeah.
Yeah. The main thing is, of course, that the data are so sparse that whatever method you use, if it's reasonable, it's more or less the same result, no matter. And all the complications that the other groups introduced didn't really buy them anything. But at least they confirmed that our primitive method is accurate enough.
So their main goal was to make it more readable and understandable, so that the normal person can go in and edit the Python code and things like that. They made a GitHub repository, so you can actually go and download their code and mess around with it.
There are no normal people here.
Yeah.
Get that out of your head right there.
The normal people using Python particularly.
Yeah. Okay. So the new GISTEMP that I've created together with Rito and Robert's help, and I thank them for that and their help and their insights, is that now it's actually a Django interface. So it's a Django application that's hosted on the web, and it supports. I've converted all of it to Python 3. I've added in a bunch of optimizations using NumPy. So now instead of using binary files to store all of the data, it's using NumPy arrays. The NumPy arrays are then saved in a compressed NumPy file, which is a lot easier to read through, a lot easier to manipulate, and things like that. It may be a little bit slower in terms of the reading and writing to it, but in terms of sustainability and being able to do more things with it, it's a lot easier. Another thing about it is that in this new interface, you can actually change some of the variables that go into the GISTEMP procedure and see how that affects the outcome of the procedure. So for example, the number of months required for a station before it's dropped, right? I think it's set at 20 or 30. You can change that and see how it affects the outcome, so that it can, sort of see how that proves, the way that we're doing it is correct, or whether, some things need to be changed. But the main thing is the data visualizations here that I've added. So there's some really cool, I'm going to show you in a second, some really cool visualizations using Matplotlib and D3 that are created from the results of this procedure.
Okay, can I ask a quick question? You said you used compressed MPZ files.
Yeah.
Why did you make that choice, and why didn't you pick something that is more generic?
I could have.
Because you know it's going to be in 10 years, this language will be dead, and then we'll be stuck reading these stupid files in 10 years.
NetCDF will still
That's
be.
what I'm saying. Yeah, we should use NetCDF for something that's a more standard.
Not for the output files, but for the temporary
For the
working
program.
files
Yeah.
So these are
really
intermediate
really
files, is that what you
so
said?
they're intermediate. They're just, it's easier to
Yeah.
integrate with Python. NumPy is easier to integrate with Python. So they kind of go hand in hand, so it's very easy to open the file and read through it in the native Python. If I was using NetCDF or something like that, I would have to import an additional module, but
You'd have to use something besides NumPy.
right.
Yeah.
I mean, but NumPy is already being used for the actual analysis,
I
so it's
understand.
already imported, so it's easier to.
I'm just fearful of getting, again, in the kind of, because before you showed how you had to use binary files, shell scripts, etc., and now you've added an intermediate replacement of shell scripts with some other thing, right? That's
Yeah.
my only
Yeah.
comment.
Okay.
It's more uniform. It's one language rather than a couple of them. But,
Yeah, because the thing is that the
and the program, since it was written after our program was developed, and you know how this works. You keep old stuff, you keep and so on. They have the advantage of knowing where they want to go, and could write a much clearly structured program.
Okay.
And so Avi then started from that and
Understand.
built it up, so we can do everything we wanted to do.
But it sounds like the temporary files, the same code is writing and then reading them, and in the end you have something else that's maybe
that's
NetCDF at the end.
the final stuff will be converted to NetCDF. So if somebody wants to download or
The final stuff will be convertible to NetCDF, is that what you said?
Will be converted.
Yeah, it'll be
Converted.
available in NetCDF.
It will be available or is
It
available?
is.
Okay,
currently
it's
is.
important to describe it properly. Is available or can be
Yeah,
available?
the final
Okay, fine.
data set. But it's not that's not used to create the plots.
Okay, fine. Thank you.
Right, yeah, okay, and then, so Matplotlib and D3 are both plotting libraries. Matplotlib, D3, what's good about D3 is that you can create web embeddable graphics. So these are graphics that you can actually place on the GISTEMP website, and people can actually interact with these graphics in so many different ways. It's a really cool plotting library it's a JavaScript plotting library that allows web interactions with graphics. So to replace, some of those old plots that are on the GISTEMP website, we could replace those with these D3 graphics. So there's basically a little bit about explaining these D3 graphics. Is that there's two ways basically to show graphics, to make web embeddable graphics. The first is using SVG, and the second is using Canvas. Not getting into the specifics, I chose to use an SVG just because it's very easy to manipulate using the DOM, which is basically your HTML DOM. You can actually target specific elements and change them. You can target actions, so like when a user scrolls over something, you can make something happen. You can make it, there's endless amounts of possibilities of ways that you can make these graphics interactive. So I didn't want it to be limited in any way. And I've also added some text support. So in the actual graphs, you can put latex symbols, so you can use degree signs and things like that. So that's all supported using MapJax, which is a library that interprets latex and displays it on a web browser. The other thing is that everything is being updated in real time. So when you're creating these plots, I'll actually show you right now because it's hard to explain without actually seeing it. So here's basically the interface. Oh. So here's what the interface looks like. It's not so nice, but you'll see the functionality of it. So this is the front page of it where you run.
Won't make that public. That's for our
Yeah.
internal purposes.
Yeah, this is for internal purposes. So you can basically go through these parameters, and there's a description of each parameter when you scroll over it, and you can change its value. and then run specific steps of the GISTEMP procedure and see what happens. So for example, if you wanted to run step 3, which is the step that does all the analysis, it actually grids everything and does all that kind of stuff. So you can do that and change a parameter, see how that affects the output, right? So I'm not going to run it right now because it does take some time to run, but I'll show you what happens when you run it. You'll get redirected to this page. And this page is basically the results page. It will give you a progress of what happened during the computation. So if you look over here, I ran it before. So it checks that all the input files are there. If they're not there, it FTPs over to the website, over to the FTP server, and downloads them. And then it creates all these graphs over here. So those graphs are here. If I click show all, these are basically all the graphs that it created, which are equivalent to this page over here. So this is actually the most clicked page on the GISS website according to the Google Analytics, and it basically shows the resulting graphs from the GISTEMP analysis. So every month these are the ones that need to be updated are updated here, and I mean they're kind of bland graphics. They're compared to the new modern ones that you can create with this new GISTEMP. So if you look over here, some of the plugins you can do. You can like zoom in on specific, you can move it around. If you want to zoom in on specific data, you can do that as well. Click the magnifying glass, zooms in.
It doesn't tell, this is anomaly, but what is anomaly? What is the base period? It doesn't tell you anything here.
So it goes from 1880 to 2015.
Yeah, but the anomaly, it's anomaly.
Yeah.
Wow.
Yeah,
What's the base period? What's the base period?
The what? The base.
period. Is it anomaly?
1951 to 1988.
Okay. So that's basically it creates all these different graphs, which are the same ones as the ones created on the GISS website, just rewritten in D3. And the thing about these graphics is that they take advantage of everything that Matplotlib has to offer. So you can because it converts the actual Matplotlib graphics vectors into D3 graphics. So you can use all of the interpolation and all the advanced features that Matplotlib offers. You can use that and then just convert it into D3. It does that for you. So let me show you the custom plotter. So you can actually create custom plots as well. You want to customize a graph from the output. So I'll go through the different fields that you can provide. So you can put a plot title here. So let's just put test, right? And this is basically the font size in points, which is the unit. The unit is called points. It's the smallest unit. You can set the plot width here, but let's go to the input file, right? So you can either upload your own input file here, or you can choose one of the input files that were generated as part of the GISTEMP analysis. So all of these files were created as part of the analysis. And if you want to take a look at one of the files, you can see, so this is the land-ocean, a mixture of the land-ocean data in the northern hemisphere. That's what this file contains. So if we wanted to plot something with this file, right, we click that file, and then it creates a plot for you. You can determine different things about the plot type. So right now there's 3 options here to plot the raw data, the 5-year running mean, which I think we're going to get rid of, and this lowest smoothing technique, which Gavin recommended. So if you want to see the 5-year running mean, you just click that, and that red line you can see pops up there. Let's see what else. So you can also choose the start year and the end year of where you want the data to come from. So let's say you wanted to only see data from 1900 to 2015, right? So it just updates it in real time right there for you, and you can actually just it just puts it right there. The data step. So this parameter is for how many pieces of data are for each year. So if you're plotting something that's seasonal, then it would be 4. If you're plotting something that's monthly, then it would be 12. This is yearly data, so I'm using 1 as the parameter there. But different files here have different files generated from the GISTEMP analysis have different steps, have different data steps. So that's why that parameter is necessary. For example, if you take a look at this seasonal means plot, you'll see that it starts in 1950, but it's seasonal. So there's four data values for each year, right? So you can plot things like that as well. What else do we have? The extract column. So that's the column in the file that you're extracting from. Right now we're using text files as these. Really, we should be using something like HT5 or something like that. But right now it's reading in these text files, which have columns in them. So all of these text files that get generated have these columns, right? So the first column is usually the year. This is just the tradition of how the GISTEMP files look. So the first column is the year, and the second one is the actual raw data, and then the 5-year mean and this lowest smoothing thing. So usually you want to plot the raw data, but if you wanted, you could also plot, these other columns as well.
Can you get the actual data instead of anomaly?
Yeah, you can actually upload your own files. If you create, say, a text file and you wanted to plot it, you can just choose a file here, navigate to it, and then select the column that the data is in. Make sure it's in the proper format, so it has to be, the year has to be either year, 4, or 12, or something like that. And then, yeah, it will plot it for you. What else do we have? So to customize, different aspects of the graph for, let's say, for a publication or something like that, you can do that as well. If you wanted to change, the color of a line, so you just come over here, you can change it to like green or whatever. There's a whole list of colors you can choose from.
Can you take the box off the legend?
No, I haven't done that yet. So you can also change the line thickness. So let's say we wanted to make the raw, there we go. So let's say you wanted to increase the thickness, so it's more, you can see it better. You can change the marker, right? So if you look closely, you can see they're like squares here. Let me move this back down. Right, you can see these squares as the markers here. You can change those to any shape that's allowed by Matplotlib. So if you click this link, it will give you a list of different markers here that are allowed, and you just put in that symbol, and it will create that for you. The line style as well. So if you wanted like a dashed line as opposed to a solid line, or different types, you can also do that. And these are the options that you can use. So let's put a dashed line. Right, so now you have that dashed line. The legend title, so you can change the size of the legend, but you cannot change that box around the legend. You can change the text that's inside the legend. So if you want this, instead of saying annual mean, to say, annual mean with the degrees or something like that, you can put it there. Let me show you the latex support. So let's say, I'm not too familiar with latex, but if we did like just latex text, like that, right? So the title changed to latex, but it's better for things like percentage signs, so like 60, see if I can remember how to do this. I need a caret. There we go. So 60 degrees, right? You can put any latex symbol is supported. That's supported by MathJax. So yeah, so that's basically, and also another cool thing about these graphs is it's very simple to customize plugins. So for example, when I scroll over a point, you see that it pops up with like the year and the temperature. I created that just to show you like the capabilities that you can do with it. You can edit any of these things in the same way you would regular JavaScript pages, and you can target events the same way you would regular HTML pages and things like that. So I can show you if you want to see what the actual object looks like. right, if we come over to here, you can actually select this and like make it bigger, right? So everything is just an HTML object, and you can customize it completely and add any type of plugin you want with just very simple JavaScript. All right, the next thing that I'm going to show is here. Right. One other thing I forgot. Let's go back. Right over here, if you want to get a PDF version of the file that you created, you just click this PDF. Right. But the cool thing here is the second option, which is HTML. So you can actually just get an HTML representation of the graph that you created. You didn't have to do any code to create that graph, right? You just fill in the parameters, it creates the graph, and then you click this HTML. It gives you an HTML file, right? So you can copy this file. And let's say, I'll put it, just to show you, this test.html. Right, let's open it with Notepad. Right, paste it into here, save it. Place. It's already open. Let's save it as something else. Let's do a new file. Paste it in here, save it, and then just change the extension to be HTML. Right, and then we open that up, and you see you get your graph just like that. It's just web embeddable automatically. So you just put that file into your web page, and it can be viewed by anybody.
But latex didn't work.
What?
Just don't use latex.
Yeah, I saw that. No, that's because I have to include, there's a JavaScript file that you have to include that does the conversion, and I didn't include that in where I put the file. But yeah.
So can you overplot two things? So I want to overplot the different seasons.
Seasons, sure. So if I choose seasonal file, so this is the actual file. So let's say we want to plot that, so we select it, and we have to change this, the step. Yeah, I might have to take a look at that. Let's just try it. Yeah, I'll have to take a look at that. I'm not sure why I'm throwing an error, but
Well,
okay.
that's easy. But so the plot you had before, and then I want to plot something, data from another file over the same plot.
You want to do what?
Overlay.
Overlay data? No, so that option's not available yet to plot two plots onto one.
Okay.
But I can add that feature.
Yeah, it would be nice.
Yeah. Okay, the next thing.
Not for you, but plot whatever you want.
I'm not thinking for the skeptics. They could
Here. Okay, let me just close it. Okay, the next thing I want to show you is the station locator. Right. So all these stations, all these NASA stations that are collecting data, or NOAA stations. So if I go to here, localhost/station, right? Alright, so right now what's going to happen is you're going to see a bunch of points. There's about over 8,000 points that are available for stations, and it will show you their locations, but it's not going to be in a readable format. It's actually still loading it right now because there's so many points, right? So I'm going to show you a way to make this visual, like a way you can visualize it better, because this is obviously not efficient for anything. I mean, you can click it and still get information about it, but it's not going to be responsive because there's too many points, and it's just going to act very slowly. So if I come in and change that file, switch it out with this one. Right, so if I rename this one, this one, I'm just changing the name so that it uses this file, this JavaScript file, and I reload the page. Right, you'll see it uses something called marker clustering. Right, now with marker clustering, it allows it to be a lot faster because you cluster markers together, and then the further you go in, the markers will expand. So it's completely responsive in this way, and you can zoom in to specific locations and find stations. And this is just a way. This is using leaflet.js, which is a mapping library that's a mapping library that's browser compatible. It also works on the mobile phone, and you can. And the goal of this is that you can actually see the data. So you can generate a plot, and it will plot the data for that station. Some other cool things is you can search for specific stations. So if you want to get like the New York City Central Park station, you have to spell it right. Central.
Came up when you did it.
There we go.
That's capital C. Okay. So right, you can see the New York City Central Park station, some information about it, its name, its ID, and another cool thing you can do is you can actually change the map background to any of these three. I've added that plugin here. So if we go to this one, right, you can actually zoom all the way in to see the actual station. Right, you can get pretty close. I think that's as close as you can get, but
That's why we can't make that version public, because then people see that because of truncation, the error is not exactly where it should be, and we get all these emails, locations are all wrong.
So it's not actually right there.
Yeah.
It's not.
that's where it's listed as in the
This
inventory
one
file.
is pretty close.
But it's the number of digits you have on this.
Right.
Yeah,
The precision is a little off.
Yeah.
Is there a way to restrict the search to like data stations with data between certain years?
So what you can do is you can check stations with that are supplying data currently. So any station that had data no longer supplies data will be removed from the map, and you can do that over here with the data sets. So there's a couple different data sets here. These data sets are all created from the GISTEMP process. So during the procedure of GISTEMP, the data is sanitized, number one, so a lot of stations are eliminated. So the basic data set is exactly the data as it's received from NOAA, right? Exactly how we get the data, we don't do anything to it. Then you get the clean data, which is removing some stations that are suspicious, things like that. Then you have the adjusted data, which homogenizes a lot of the data. It fills in missing data, things like that. And then over here you can get the new data, which will give you any station that's supplying data currently, right? So it's obviously a lot fewer.
I have a stupid question. I've never thought about it too much, but it's not a skin temperature, right? Is it a specified elevation above local ground, or?
No, since we use anomalies, it doesn't really matter.
Oh, I see. Right.
Yeah.
Interesting.
Yeah, that's
So to
another
get
thing.
the
So
data
wherever-
and not the anomalies is a different thing.
Yes.
It kind of doesn't exist in a way.
Right.
Okay, I didn't know that.
Yeah, no, we always get asked for absolute temperatures.
Yes.
Right.
Don't know. How do you find the absolute temperature for New York State? Don't have enough thermometers to
Right.
get anything close to it.
Alright, so that's the map, and then two more types of visualizations I want to show is this one here, which is the base maps. So Matplotlib has a base maps library where you can actually plot the temperature data on a base map, and that's what this is here. This is a base map plot from Matplotlib. And you can change, you can set these parameters here. And it will update. Takes a couple seconds. There you go. And it updates. You can change the projection because they actually support more projections than we have here. They support like 20 projections, and then you can add other libraries in to allow for additional projections. But yeah, you can see the data in different ways, so you can visualize it differently.
So can you do it as pixel maps instead of contours? Because contours are evil.
Yeah, you can do it as pixel maps as well, using like a scatter plot.
No. Just you have areas that have colors. I mean, you.
No interpolation, you mean?
Oh,
yeah,
no
no
interpolation.
Yeah.
Slower, but
So it's like
I don't know
pixel
whether we
replication
have
instead
that
of contours.
we don't have that option yet. But I think it's
I
possible.
mean, we obviously Nmaps has it.
Mm-hmm. Well, contours are just terrible because it adds information. I mean, I think.
Or hides information.
What's that?
Or hides information.
Or hides information. But I mean, it's only if you have fully gridded data can you get away with it. Maybe this data set is not really good for that sort of plot.
Eventually, like a world that we can rotate, rather than just having these two
Right.
projections.
Be able to
A
spin it.
single, and you can move it around
Yeah.
and look at the plot you're interested in.
Yeah, so that's something that we're working on that. That's also going to be in Deep3, so it'll be something like this where you can rotate it.
And you can zoom in.
Yeah, this is what this is what I'm working on now to try to make it better to interact with. But there's just so many different types of ways you can visualize your data like that. The last thing I want to show you is a 3D isosurface graphic that I created with Jeff. Jeff's here, yeah. So if this actually takes the input to this program is actually output from the climate model. So it takes in different information from there. I'm not exactly sure what it, but here if I run this, right? So it creates something like that, which is representative of this this 2D plot here.
Were you looking at it, the ozone anomalies, the QBO? So when we got as many of you know, we started getting the QBO working with the model AR5V1, the hybrid. This is from the 102 layer. So when we started digesting all day, we started to take a look at the ozone. Sure enough, it was reflected in the ozone. When you're looking at the ozone anomalies over the years, over I think last 12-year period, it's the zonal average across the equator, and and then there's I forgot which color is which, but not negative and positive. I think it's plus or minus. But it comes up very clearly. The quasi-biennial oscillation every 2 years, so you're seeing it repeated. The x-axis is time. I forgot how many years we have there. That's 12 years. 12 years. 144 months he has going across. That's 12 years. So anyhow, it came out really nicely.
Yeah, and by setting the opacity of the contours, you can actually see inside of them, and you can see if you were to take this and simulate it over time, you could see how those change over time, and you can see inside of them. So what we actually did is we took like the min and the maxes and just visualized those. Everything else is that like greenish bluish color that you see. And by doing that, you can see how the min and maxes change, and you can see inside them which parts of them are changing, and you can create some really cool simulations that way. But yeah, that's basically it. I hope, my goal of this was to show you things that you can do with your data to relate to it better, things that you can do to interact with your data, ways that we can, change, update things on the GISTEMP website to use more interactive and modern graphs as opposed to, some of the older things that are on there. And yeah, that's basically it.
Or any other website.
Yeah, or any website.
More questions? Okay, great.
Oh, one other thing, if there's any interest, I am hoping to give a Python course to people who, if you have no experience with Python, or if you have, if you want to learn more about Python, if there's enough interest, I would love to give, a course, starting from the basics. So if you've always wanted to learn Python, or you want to learn a newer programming language or something like that, I think Python is a great place to start because of the different libraries it has for scientific development, and the visualization libraries that it has are tremendous compared to other programming languages, and they're very simple to use. Also, you can just simply import them. It's just like a one-line import statement. One other thing I'll end off with is just to show you some of the libraries that I used, which are these here. So yeah, if you were interested in any specific part of the presentation, I would encourage you to look at some of these libraries. Anaconda is a must if you want to use these types of things, because it has everything built in. It creates your environment for you, and you can play around with it on your local machine. Otherwise, it will take you a while to set everything up. And so, yeah, these are basically the things I used. And I'll be sending out an email to see if there's interest in a Python course.